Hello everyone, welcome to tutorial 9 of the course. So, today we will be covering prompting techniques. So, effective prompting techniques for large language models. So, here we will use the Llama's open source 3.2 billion model for different prompting techniques, and we will get started with what is prompting and so on and so forth. I think sir has covered quite a lot on this prompting techniques, different types of prompt, and there is huge amount of research that is being conducted right now on prompting and how we can guide LLMs with the help of prompts. So, what is prompting? So, prompting is the process of providing an input to guide an LLM's output. The way you formulate your prompt significantly impacts the quality, relevance and accuracy of the response. So, why is prompting important? Directs model behavior, improves output quality, overcomes limitations and enables complex calculations. So, we will first you need to first create an account into Hugging Face, where you can you have to set the access tokens for for accessing different models that are gated, that are restricted. So, like let us say for Llama 3.2 that we will be using. So, this was a gated model, and so here there will be a form. When you will visit for the first time, you need to fill up a simple form and you will be granted access within 1 day. So, this is a gated model. Okay, so then so here there are access tokens. So, with these tokens we need to log in to Hugging Face to access these models. So, Hugging Face CLI login does that, where we need to provide the login token from Hugging Face and just logs in. So, again using Hugging Face we will write a simple function for torch, auto tokenizer, auto model for causal LLM, since we would be using LLMs and they are decoder only models. So, this is the causal LLM, and there is a function known as pipeline, which does things one after the other. It is a pretty neat pipeline, neat API to work with. And again set devicing device. So, this is the model ID for the tokenizer, then we define the model, load the model. So, you can use bits and bytes. Bits and bytes is a library for doing quantizations, 8-bit, 4-bit, and so we are not telling the model, we are not doing quantization here, but we are telling it to load the weights in bfloat16 for a little faster inference, and device map, which tells the model where to load the weights, whether in the CPU or the GPU, if a GPU is available. Like for our case, I am connected to T4 from Colab, so auto prefers GPU over CPU. Now, we create a text pipeline. So, first then it goes the name, then the model tokenizer, the max new tokens is the number of new tokens that the model will generate. So, it is 512 here. Temperature, to set the temperature for the model. Now, top P, so top P is one of the sampling techniques that sure sir has covered in his lectures. Top P we are setting to 0.9, and repetition and penalty, we will penalize the model when there is a repetition, right. So, then we define a small function which provides us with responses, right. So, now to get responses, when we give a prompt and to get responses, we need to make the prompt such that the model accepts it. So, Llama 3.2's preferred prompt is like this: begin of text, user, prompt and assistant. So, this is one of the templates that Llama 3.2 uses. So, and there are also other templates like the Stanford Alpaca. Let me show you. So, this is one of the first models, Stanford Alpaca, and instruction following Llama model. So, how the instructions, how the prompts are being formatted was I think popularized by Stanford Alpaca model. And so, these guys, Stanford Alpaca accepts the prompt in this way. So, below is an instruction that describes the task paired with input that provides further context. Write a response that appropriately completes the request. Then there is instruction, input and response. So, this is the template that Stanford Alpaca was trained on, right. So, these now different models will have different kind of chat templates. So, we need to create the formatted prompt in such a manner that its preference depends on the LLM that we are using. Let us say you are using Mistral. So, Mistral might have a different chat template. So, let us say you are using these closed source models like OpenAI, you are using the API key from OpenAI. So, that might have a different chat template. Okay. So, you need to take care of this chat template very well, so that the quality of generation that the model is providing is very good. And then we are doing a response. So, pipeline, it goes the formatted prompt, max new tokens, temperature, do sample equals to true, end of sequence ID is tokenizer end of sequence ID, and pad the token ID, pad token ID is tokenizer dot pad token ID if it exists, otherwise EOS. Now, assistant response is response dot. So, assistant would also provide this and this, but we do not want this to be in the generated output. So, you would just split them on this and take it and take the response after that, and also split, and there will be end of text at the end of the sentence. So, we would remove that as well. So, this basically removes the assistant and the end of text words from the response that the model is giving. So, let us in the interest of time I have run it. So, this downloaded the model and so on and so forth. So, device was set to CUDA. So, and so model response. So, I had given hello, how are you today. So, model had responded, I am just a language model. So, I do not have any feelings or emotions like humans do. However, I am functionally properly ready to help you with any questions, tasks that you may have. How about you? What brings you here today? Llama is not feeling well today, it is in a cranky mood. Alternative, that you can also use Ollama, that is a good interface for local inference. Ollama is a very good software that you can use it for all Llama models are there on Ollama. It has a very good documentation also, and I think these guys now support DeepSeek R1 also. So, go ahead and start playing with that. So, we will start with basic prompting techniques. So, direct questions, this is the simplest form of prompting, is asking direct questions. This should be clear and specific. So, like what are the main causes of climate change, like, right. So, get Llama response calls the function from here and it generates output like this. It takes a bit of time, since it calling Llama a 3.2 3 billion model, and so yeah, we are calling the 3 billion model, and then it is generating, and so it generated. So, as you can see, climate is a complex and multifaceted issue, and blah 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 blah. It has generated a lot of things, and also it has generated the sources. Wow. Now, task instructions. So, clear instructions can guide the model to perform specific tasks. So, like summarization, translation, and so on and so forth. Question answering, like summarize the following paragraph in 3 sentences. So, we are telling it to summarize and also to in 3 sentences. So, here there is 1, 2, 3, 4, 5, 6 sentences. So, let us run it. Now, also we can for so yeah. So, no, I will provide a summary in 3 sentences. Here is a summary like AI and so on and so forth. So, formatting instructions, you can request specific outputs to format specific output formats to structures the model response. So, like we can also make the model to structurally output something like in a JSON format or CSV format or and so on and so forth. Let us say this is a prompt like list 5 benefits of regular exercise, and we are also telling the model that format your response as a JSON object with the following structure. So, benefits, title, description, scientific evidence, and so on and so forth. Let us see what the model outputs. Would it be able to output a JSON format? Let it run. In the meantime, we would go over this advanced prompting strategies. So, one of them is context setting. So, providing context helps the model understand the background and requirements better. So, I think Llama has generated. So, benefits, title, improved cardiovascular health, description and scientific evidence. So, 1, 2, 3, 4, 5. Yeah. So, as you can see, Llama has generated 5 benefits of regular exercise. So, where were we? Yeah. So, advanced prompting strategies. So, context setting. So, for a task, if we tell the model, if we give the model some context, some background on what the task is, the model can output better coherent response in the same way as a human does. So, let us say what is the context is. So, this is the context, we specifically write it like context and the task. So, context is you are writing an email to a potential business partner who has expressed interest in your sustainable fashion startup. They are particularly interested in your sourcing practices and environmental impact. So, task is draft a professional email response addressing their interests and proposing a meeting to discuss potential collaboration. So, we have given a context to the model, and also we have defined the task for the context. Let us see what the model generates. Yeah. So, it has generated an email like thank you for your interest in your startup name, dear partner, and so on and so forth. So, it has, I won't go into the details of the email, but it has generated an email with subjects, and like the format is pretty good. The format is pretty good. Now, constraint specification. So, we can also set clear constraints. Let me run it first. We can set clear constraints that guide the model to stay within specific boundaries. So, like constraint prompt is write a short story about time travel with the following constraints. So, maximum is 250 prompts. So, these are the constraints. So, short story about time travel. So, the constraints are maximum 250 words, include exactly 3 characters, then set in both past and future, include a paradox, and so and as many you can wish to give. Like so, so as you can see, in the year 2154, scientist Emma Taylor stood nervously beside her colleagues Dr. Patel and Jackson Lee, and this is a story about time travel. Llama has generated. Role based prompting, like assign specific roles to the model that can help tailor responses to a particular perspectives or expertise. Like in this way, we can guide the model that what is the model acting as. Like so we can say that you are an experienced data scientist, or we can say you are a doctor, or we can say that you are acting as a chef, provide me with a recipe for something that you want to eat. So, you are asking here in our example, you are an experienced data scientist specializing in machine learning. A junior colleague has approached you with the following problem. As I am trying to build a classification model, but I am getting poor accuracy. My data set has 1000 samples, 50 features, but it is imbalanced with only 5% positive cases. What should I do to improve my model? Provide expert advice on how to address this problem. So, we have assigned a role to the Llama model or any LLM, like it is an experienced data scientist, or similarly persona based prompting, like similar to role based prompting, but focused on adopting specific personalities or writing styles, like in the style of write a brief explanation of quantum computing, in the style of a children books author, a technical paper, a comedian, and so on and so forth. So, any personality that is whose personality is is available on the internet, and it might have been in the pre-training data, or I mean that author or that celebrity might have a Wikipedia page, then these LLMs obviously has gone through that Wikipedia page. We can also write a brief explanation of quantum computing in the style of Einstein, Hawkins, Stephen Hawkins, let us say quantum computing in the style of some comedian, and so on and so forth. These are persona based. So, these are personality based prompting. Now, moving on, we have what is something known as chain of thought prompting. So, chain of thought prompting encourages the models to break down complex problems into step by step reasoning. So, I encourage you to go through the paper. So, this is what the standard, this is the paper from Google. So, this is the what standard prompting is, like we give the model a math question and we tell the answer. So, this is one shot prompting. Okay, we give the model a sample question answer, then we provide it with a question, the model output the answer is 27. But the chain of in the chain of thought prompting, we provide the thinking process, we try to provide the thinking process in the form of text, like Roger has 5 tennis balls, he buys 2 more cans of tennis balls, each can has 6 balls, how many tennis balls does he have now? So, Roger started with 3 balls, 2 cans of 3 balls is 6 tennis balls, and 5 plus 6 equals to 11, the answer is 11. So, we have provided some step by step reasoning that we humans would do when we encounter these kind of problems, and we provided this in the prompt itself. So, it is chain of thought prompting, like we are putting our thoughts in the form of a chain one after the other. So, yeah, so this is example of input, chain of thought and output on academic, common sense and symbolic reasoning benchmarks. So, these are math problems, this is multiple choice, this is free response, and this is common sense reasoning, right. So, there will be a question, there will be a reasoning based answer, and there will be an answer. So, these are the chain of thoughts. So, the highlighted are the chain of thoughts associated with each of the tasks. Please go through this paper, super important. So, the COT prompt. So, problem is a. So, we will go for 0 shot prompting. So, a store has a sale where if you buy 2 items you get the third for free. If each item costs $20, how much would you pay for 7 items? And we are also explicitly telling the model that please solve this step by step, showing your reasoning. Let us see what the model outputs. So, as you can see on math word problems, this is fine tuned GPT-3 175 billion. This is the best that was there. This is standard prompting PaLM 540 billion. Then this is PaLM 540 billion with chain of thought prompting. So, a huge jump on math problems, math word problems from 18 to 57 just with the change, just with the introduction of thoughts or reasoning steps in the prompts. So, our LLM Llama 3.23 billion has done it. So, step 1, step 2, step 3 and so on and so forth. Please go through the notebook to judge whether these steps are right or wrong. We will provide the link to the notebook in our course website. Similarly, we have on top of it a self consistency with chain of thought. Now, what is that? So, self consistency with chain of thought is self consistency improves chain of thought reasoning in language models. Again a paper from Google accepted in ICLR 23, super important paper. So, what it does? It improves upon the standard chain of thought prompting. So, as you can see in the top, so there is a prompt we provided to the language model. Then what the language model does is what is called greedy decoding or greedy sampling, right. So, it takes the first thing that comes up and it decodes, the sampling is greedy decoding and it generates the answer. But what self consistency method says that it contains 3 steps, right. The first, prompt the language model using chain of thought prompting. Then the main step, replace greedy decoding by sampling from the language model's decoder to generate a diverse set of reasoning paths. And third is marginalize out reasoning paths and aggregate by choosing the most consistent answer in the final answer set. So, what does it mean? Is that we provide a question answer and we ask a question to it, similar like one shot, similar to standard COT. So, and we provide the reasoning steps also, but instead the model, instead of giving out one answer, it will generate a sample of diverse set of reasoning paths. So, different set of reasoning paths, as you can see it has, I mean this we can control, this is a hyperparameter, but here it is shown like the model will generate 3. So, let us say the model generated 3 reasoning paths and which leads to 2 of the answers which were right, or the model generates 2 answers which are right and 1 answer which is wrong. So, out of these we will marginalize out reasoning paths to aggregate the final answer. So, here we kinda take the majority voting, the reasoning paths that had taken the the mostly we will take that, and we have some other strategies also that the model takes. Please feel free to go through the paper, super important. Yeah. So, similarly, for this model we would generate. So, please solve this step by step. So, in the previous step showing your reasoning, and so we are using a higher temperature and a more diverse solutions. So, we are telling the model to generate 3 solutions and temperature of 0.8. So, previously I think in the Llama, the function that we used a temperature of 0.7 default temperature, but we want to use more diverse outputs. So, more diverse solutions. So, we used a higher temperature, and so we provided it with a problem. If it takes 5 machines 5 minutes to make 5 widgets, how long will it take 100 machines to make 100 widgets, right. So, the model has generated solution 1, solution 2, solution 3. So, 3 reasoning paths that the model has undergone, and out of that there will be the step where we marginalize and take out the solutions. And few shot learning. So, few shot learning, I think it first came into the GPT-3 paper, not sure, but it was the popular it was language models are few shot learners, the GPT-3 paper, super important. So yeah, so this is few shot. So few shot, like, so this is zero shot, translate from English to French, cheese. What is the so the model will, so we are asking the model what will be here. One shot, we would give one example to the model. What is that? Then we have few shot, where we are asking the model from English to French, but we are providing more than one samples or examples of which are true. So, sea otter, the ground truth, peppermint, the ground truth, plus giraffe, the ground truth. Then we are asking the model for cheese, what is the French of cheese. So, this is few shot prompting. So, what the LLMs can understand what we are asking it to do based on this few examples. So, this is also something known as in context learning, where we provide few examples and it can learn from those examples that what the user wants. So, a few shot learning provides examples of desired inputs and outputs to guide the model's response. So, here is few shot prompting. So, convert these sentences to French. Hello, how are you? Something in French that I can't pronounce, but we are asking the model that English, I have a meeting tomorrow, what is the French of it? So, the model has responded something, I am not sure whether it is correct or not. Let us put it to Google Translate and check whether the model did correct or okay. I have a meeting tomorrow morning, the model was correct. So, then we have few shot with varied examples. So, providing diverse examples helps the model to generalize better, as we all know. So, classify these customer messages by sentiment, positive, neutral, negative, and urgency low, medium, high, and then we provide some examples and we want the model to classify this. So, as you can see, note that the model force sentiment, that the message force sentiment can't be classified as purely negative, positive or negative without more context. It may be slightly positive is if the customer is relieved that someone will investigate the issue, but it could be neutral if they are asking for clarification rather than expressing strong emotions. So, like the message was, there seems to be a mistake on my bill, can someone look into it. So, yeah, it can't be purely positive or negative, the model needs more context rather than this one sentence. Now, since we have gone through a few of the prompting techniques, we would now go through what are the prompt engineering basic practices. So, let us so the first would be clear and specific, do not write a lot of things, and also do not be completely vague about something that you want the LLM to output. So, like a vague prompt would be tell me about AI. A specific prompt will be explain 3 key milestones in the development of artificial intelligence between 2010 and 20, focusing specifically on the breakthroughs in NLP. For each milestone include blah 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 blah. So, this is a specific prompt that you want the model to. Now, let us see what is the difference between a vague prompt and a specific prompt. So, for this model will take a bit of time. I will move on with the rest. So, use structure outputs. So, when you use structured outputs or do structured generation, now again structured generation from LLMs is a hot research topic now. you should obviously go through or search, read NeurIPS, ICL or ICML star ACL papers on structured generation from LLMs. They are really a hot research topic now. So, use structure outputs. So, structured outputs, clear structure helps guide the model's output. So, let us say we give the prompt, analyze the short story for its literary elements present in your analysis in this format. So, summary, 2-3 sentence summary of the story, then summary. So, this is the summary, this is the characters, these are the themes, these are the literary devices. So, we want the model that when given a story, the model should output in this format like summary, characters, themes, literary devices and so on and so forth, such that the model can understand what are the main things that it needs to provide to the user. Now, let us run it. Now, in the previous response, so the difference where we left back vague prompt and specific prompt. So, vague prompt, what is an AI? And AI refers to this and so on and so forth, and it was pretty, I mean the same thing that it is not pinpoint. So, key milestones. So, in the key milestones in year 1, researchers Google team this and this, maybe they are referring to AlphaGo. I am not sure. Please increase this max new tokens to get understand what the model is trying to say. Now, let us say, so it was provided, it had to generate here the summary characters in this format when given a short story. So, characters, old man, boy, theme, optimistic, pessimistic, perseverance, literary devices, imagery and so on and so forth. Similarly, you can control the output length. Okay. Explain quantum computing in 2-3 sentences, write a comprehensive explanation of quantum computing in approximately 500 words, give me a tweet length explanation of quantum computing, maximum 280 characters. Right. Moving on, we can also use LLMs for practical examples. Now, let us explore some real world examples like content generation, creating a blog post with specific requirements. So, task is create an engaging blog post about sustainable living. Task, we can specify the target audience, the content requirements like approximately 500 words, include attention grabbing headline, then include 5 practical time efficient sustainability tips and so on and so forth. And also we want the model to make it in a format with proper markdown for web publishing. Similarly, data analysis, use LLMs to help with data analysis tasks like this is a customer review. So, data analysis tasks like it can generate now code LLMs or even ChatGPT can generate Python code, where you can ask like this, load and clean the data assuming it is a CSV file, and in steps also include comments in the code behind analytical choices and so on and so forth. It can also generate code out of it. So, let us see how much. So, and also this is the data that the model can expect from the data like rating, review ID, rating, date, version, text and so on and so forth. Let it generate. Also problem solving. So, use role and chain of thought prompting for complex problem solving, like so this is persona based prompting. You are a senior software architect with the expertise in system design and optimization, then you decide the problem, you tell it what the problem is. So, using your expertise please, and also think step by step for reasoning task for chain of thought. Okay. the model so there must be some problems. Please use a data set. I don't know what is this message is it coming from Colab or this? I think it's coming from Colab, not sure, or is this Llama speaking? I am not sure. Oh, this was Colab. Okay. Okay, let's show the output. So only this was still, so we have to increase our max new tokens. These were only 1500 tokens. So as you can see, it had imported pandas, numpy, matplotlib, seaborn, and it was reviews for a software product. So date, so there was text involved. So we are using NLTK. Then sklearn for TF-IDF vectorizer, we are using PCA, then trend test split. Then for metrics, we are doing accuracy score, classification report, and confusion metrics, and it couldn't generate more because number of max tokens was done. Now, with all this, there comes model limitations and considerations. So, while Llama 3.2 3 billion model is a powerful open source model, but it has some limitations compared to this larger commercial models like Claude from Anthropic. Then we now have DeepSeek R1, then there is obviously ChatGPT, O3 mini, O3 and so on and so forth. So, there are knowledge limitations, context window, quantization effects, then hallucinations, then performance requirements, right. So, the conclusion is, the key takeaway is clarity and specificity are fundamental to good prompts. Different techniques, role based, few, short based, chain of thought serve different purposes. Structure and formatting guidance improve output consistency. Evaluating and iterating on prompts leads to better results. Open source models like Llama 3.2 3 billion provide powerful capabilities without requiring API access. I mean, these are open weights models, so you won't require an API such as GPT, ChatGPT. The best prompting techniques depends on your use case and the capabilities of your chosen model, right. So, ChatGPT being a bigger model, we are not sure how big the model is. So, it can, I am not sure, it might generate a code that is better than what Llama 3.2 only a small 3 billion model can generate. So, depending upon your usage, you should choose the model and the prompt, and how are you prompting the model to do your task. So, that is all for today. See you in the next tutorial.